600 years ago, the Inca Empire managed a sprawling territory across the most rugged terrain on Earth. Running a society this large required a massive, tightly coordinated administrative network. Yet the Inca are the only major Bronze Age civilization of this scale to operate without a written alphabet or script. For centuries, historians dismissed the system they used, the Quipu, as a basic numerical ledger, a simple string abacus used to count crops and keep tally. But a state of this size generates massive amounts of data. To survive, the Inca had to track regional census numbers, calculate shifting tax burdens, manage labor drafts, and coordinate supply chains across thousands of miles. A primitive numerical tally cannot explain the operational survival of a civilization managing that level of complex, layered information. Recently, computer scientists and linguists analyzed the Quipu through the lens of modern data structures, discarding the calculator theory entirely. They found a three-dimensional analog to a modern computing system engineered directly into the fibers of the cord. The individual knot varies significantly in shape and tying style. They are not simple placeholders for numbers. Up to 95 distinct symbols function as linguistic markers. In isolation, a knot is a blank variable. Complex meaning derives strictly through positional relationships and specific color coding. Decoding a Quipu requires understanding its modular structure, operating identically to modern databases that organize data through contextual relationships. Zooming out reveals the main cord, a thick horizontal backbone from which the rest of the system originates. Researchers discovered these secondary strings branch off the central cord in a strict layered hierarchy. This physical hierarchy mirrors a tree-like data structure, the same algorithmic logic used in modern object-oriented programming like C++ and Python. Utilizing a hierarchical tree achieved massive scalability. They processed layered administrative data from diverse geographic regions and accessed it instantly. The Inca engineered a physical algorithm capable of processing the operational data of an entire state. Moving sensitive imperial data across vast territories creates a major security risk. The Inca needed a way to protect that information from unauthorized readers. Modern data security typically applies a mathematical lock or a separate encryption protocol over an existing file. The Quipu uses a structural model for data protection. Scrambling the physical arrangement of the cords at different levels of the hierarchy obscures the information. The organization of the data itself acts as the cryptographic lock. Security is an embedded property of the structure, not an add-on feature. This recontextualizes the historical paradox. The Inca bypassed two-dimensional writing entirely to build a three-dimensional data modeling system. Computer scientists are now translating these physical properties into modern programming logic. Researchers have developed a new digital file format designed around these same hierarchical Quipu principles. This ancient logic allows us to run complex simulations, stress test data scalability, and improve modern data visualization. Modern digital code is fragile, often requiring constant migration to survive a decade. This physical code has survived 600 years. The Inca wove executable code into the very fabric of their empire, creating a record-keeping system as durable as the stone of their cities.